For this free response question, calculators are permitted. It says the graphs of the polar curves r equals 3 and r equals 3 minus 2 sine of 2 theta are shown in the figure from 0 to pi. So you can see here's your figure. This circle right here is described by the equation r equals 3. And then we have this curve right here that's described by the equation r equals 3 minus 2 sine of 2 theta. Part A says let R be the shaded region that is inside the graph of r equals 3, which is the circle, and inside the graph of r equals 3 minus 2 sine of 2 theta. Find the area of R. So if we look over here at the shaded region, you can see that if you start at theta equals 0 and you rotate up to pi over 2, that shaded region is bounded by the curve that's described by the equation 3 minus 2 sine of 2 theta. Then if we keep going from pi over 2 to pi, you can see that this part of the shaded region is bounded by the curve r equals 3. So we're going to set up two integrals. The first one is integrating from 0 to pi over 2, and again that's with the curve 3 minus 2 sine of 2 theta. And then the second integral is going to be from pi over 2 to pi, and that's going to be bounded by the curve r equals 3. And just a reminder, to find the area of a polar curve, the formula is the integral of 1/2 r squared. So since we're setting up two integrals and they both have 1/2, I'm going to factor that 1/2 to the front. Then we have the integral from 0 to pi over 2. And remember, from 0 to pi over 2, we're using the formula 3 minus 2 sine of 2 theta. So that's going to be our r value that we plug in right here for r squared. Then we're going to add the integral from pi over 2 to pi, and again from pi over 2 to pi, we're using the formula r equals 3. So now that we have everything set up, we're going to plug this into the graphing calculator. So I pressed y equals, and we have y1 is going to be 3, and then y2 is the other equation 3 minus 2 sine of 2 theta, or in this case I put x. And we're going to enter this entire expression, so I'm going to start with 1/2. So we get 1/2, and then I'm going to use parentheses, and then we're going to go math 9, and we're integrating from 0 to pi over 2. And remember this 3 minus 2 sine of 2 theta, I put that in under y2, so we'll call up that function. So alpha trace and then y2, and then we want to square that, and then we're going to go dx, and then we're going to go plus, and then math 9 again. This time we're integrating from pi over 2 to pi, and then we're doing 3 squared. And again, that's dx, and I'm going to close the parentheses and press enter. So we end up getting 9.708. So the area of the shaded region R is 9.708. Part B says for the curve r equals 3 minus 2 sine of 2 theta, find the value of dx d theta when theta is equal to pi over 6. So since we want to find dx d theta, first we need to write our equation for x. So the equation that relates x with theta is x equals r cosine theta. In place of r, we're going to substitute 3 minus 2 sine of 2 theta. So you can see I replaced r with 3 minus 2 sine of 2 theta, and then I dropped down this cosine. So now we have our equation of x with respect to theta. We need to find dx d theta when theta is equal to pi over 6. So we're going to plug this into the calculator. So we're going to use the function math 8. So we press math, and then number 8. We're going to take the derivative, so it's d dx. And then remember, we already have the equation 3 minus 2 sine 2 theta as our y sub 2. So I'm going to quit out, and we're taking the derivative of our y sub 2. So we're going to call up that function, so alpha trace y2, and then we're timesing that by cosine theta, and we're plugging in pi over 6. All right, so this is the derivative of this function where theta is pi over 6, and we're going to press enter, and we get negative 2.366. So for our notation, we have dx d theta such that theta equals pi over 6, and again our answer is negative 2.366. All right, and there's our answer. For part C, it says the distance between the two curves changes from 0 to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. We're considering the distance between the two curves between 0 and pi over 2, so that's going to be here in quadrant 1. So you can see here's your curve r equals 3, and then here's the curve 3 minus 2 sine of 2 theta. And when you think about starting at 0 and then rotating out an angle, you can see that the distance in between the two curves starts off small, and then the distance between them gets larger right here, and then the distance gets smaller as you get closer and closer to pi over 2. So mathematically, to represent the distance between the two curves, it's going to be the outer curve minus the inner curve. So the outer curve is r equals 3, and then we're subtracting the inner curve, which is the 3 minus 2 sine of 2 theta. And then to simplify this expression, we're going to distribute this negative. So we get 3 minus 3, which is 0. And then when we distribute this negative to this expression, we get positive 2 sine of 2 theta. To find the rate at which this distance is changing with respect to theta, we're going to take the derivative of this formula with respect to theta, and then we're going to plug in pi over 3. So notation-wise, it's d theta, such that theta equals pi over 3. So again, we're going to use math 8. So we select math and then 8. And then we're going to enter x. And we're taking the derivative of 2 sine of 2 theta. Finally, we're going to plug in pi over 3. And then we'll press enter. So it says negative 1.999 and it keeps going. So when we round this to 3 decimals, it bumps it to negative 2. So the rate at which the distance between the two curves is changing with respect to theta, when theta is specifically pi over 3, is negative 2. Part D says a particle is moving along the curve r equals 3 minus 2 sine of 2 theta, so that d theta dt equals 3 for all times t greater or equal to 0. Find the value of dr dt when theta equals pi over 6. So I set this up. We have that dr dt equals dr d theta times d theta dt. And you can see that this is mathematically equivalent because these d thetas technically cancel out. So you get dr dt equals dr dt. So with this equation, we can take this r equals 3 minus 2 sine of 2 theta, and we can take the derivative and substitute it in right here. So again, the derivative of r with respect to theta, the derivative of 3 is 0. The derivative of this negative 2 sine of 2 theta is going to be negative 4 cosine of 2 theta. So dr d theta is negative 4 cosine of 2 theta. And right here we have times by d theta dt, and it says in part D that d theta dt equals 3 for all times t greater or equal to 0. So for d theta dt, we plug in 3. And finally, we want to find dr dt when theta equals pi over 6. So we're taking this expression and we're plugging in pi over 6 for theta. So I have negative 4 cosine of 2 times, and then we're going to go pi over 6, and then we times this by 3. So we end up getting negative 6. All right, so dr dt when theta equals pi over 6 is negative 6. All right, guys, thanks so much for watching, and please subscribe to my YouTube channel, Math with Yosh, and hit the like button. Take care.